Now that we've covered these measures of association, let's talk about hypothesis testing. So the first concept to understand here is the null hypothesis. The null hypothesis is often that there's no relationship or no effect between the two variables that we're looking at. So for example, in the heights example that we've been discussing, the null hypothesis would be that the heights in the two groups are equal, or in other words, the difference in heights is 0. Returning to this real example, the comparative analysis of alcohol control policies in 30 countries that we've been discussing, the null hypothesis is that there's no relationship between alcohol policy score and the annual per capita alcohol consumption. So in hypothesis testing, we're evaluating whether this null hypothesis is true. And in order to evaluate that null hypothesis, a statistical summary known as a p-value is often calculated. You can find this in the medical literature, often denoted as p equals something. So in the case of the alcohol control policies, the reported p-value is 0.001. So we're going to come back to this at the end, but that's what it is in this particular study. So a p-value is basically a single number statistical summary that falls between 0 and 1. And it's interpreted as the probability of seeing something as extreme or more extreme given your null hypothesis is true. That last part is really important, and often people don't remember that's part of the interpretation of a p-value, that it's calculated under the null hypothesis. And so the assumption here is that your null hypothesis is true. I'm just going to say this one more time because I think p-values, again, like confidence intervals, can be tricky to interpret. So a p-value is the probability of seeing something as extreme or more extreme given your null hypothesis is true. So revisiting that heights example, the null hypothesis is that there's a difference in heights of 0, or that the heights of the two groups are equal. And the observed difference in heights, that point estimate, is 7. From the uncertainty from the previous section that we discussed, that 95% confidence interval for the point estimate is 6.2 to 8.7. The p-value is going to be less than 0.001. So this means the probability of seeing something as extreme or more extreme than what we observed, so a difference of 7 with a confidence interval of 6.2 to 8.7, if there really was no difference, so if really the difference between the two groups was 0, is less than 0.001. Okay, so coming back to this alcohol control policy study, we know that the p-value here for the comparative analysis of alcohol control policies is 0.001. So that means the probability of seeing a point estimate of 1, so seeing a 1 liter absolute decrease in alcohol for every 10-point increase in score, with a confidence interval of 0.4 to 1.5, if the true difference was 0, is 0.001. So researchers often use p-values to determine what's known as statistical significance. And so this means that the p-value is less than some predefined cutoff. And often in the medical literature, this cutoff is set to 0.05. So a result is considered statistically significant if the probability of seeing something as extreme or more extreme than what was observed under the null, so given the null hypothesis is true, is less than 5%. So it's really important to remember that statistical significance is not equivalent to clinical or scientific significance. So a result can achieve this arbitrary 0.05 cutoff, but not actually be meaningful in practice. And this is largely due to that relationship that we've been discussing with the sample size and uncertainty. So remember how we've shown that as sample size increases, uncertainty decreases. So this lets us detect smaller and smaller effects that can achieve statistical significance as our sample size gets larger. Okay, so here's a plot to kind of demonstrate that. So I've plotted the an effect measured at different sample sizes. So the dashed line here is the null hypothesis, the blue dot is the point estimate, and the line represents the confidence interval. So this point estimate is very close to the null, and therefore it's not clinically significant. There's not a clinically significant difference between the null hypothesis, that dashed line, and this point estimate, those circles. So notice when n is 100, the confidence interval is the largest. so it includes the null or the no effect line. When n is 200, the point estimate remains the same, just barely above the null effect, but that confidence interval is getting slightly smaller. And when we get up to when n is 800, while the point estimate is still the same as the previous samples, and so it's still not clinically significant, the confidence interval is much, much smaller, and it no longer touches that dashed line or touches that null hypothesis. So this sample would actually achieve statistical significance. But just because it achieves statistical significance doesn't mean it's actually clinically meaningful. So this is a crucial concept to keep in mind when you're evaluating studies in the medical literature. You want to make sure that things that are statistically significant are also clinically or scientifically meaningful.